Alright, so the second example has us modeling population growth, and so we're going to do this with an exponential growth model. The exponential growth model, if we go back to our parent functions, it says this: y equals ae to the bx. Alright, so x is our input and y is our output. In this situation where we're dealing with fruit flies, the input is time, is days, and the output is number of flies. So we've got 100 flies after 2 days. And we also have 400 flies after 4 days. Sorry, not 400 flies, 300 flies. So after 4 days, there's 300 flies. And after 2 days, there's 100 flies. And now we need to come up with a model for 5 days or 6 days or any other prediction. So the key here is we need to figure out what these constants are, A and B. A and B. The good news is, so we have 2 variables missing, but we do have 2 equations, so we have enough to solve this. So we're going to go through this. The key on this is we're going to solve for one of our missing variables. And we'll start by solving for A, because it's easier to solve for the variable that's not in the exponent. We'll plug it into the other equation, and we'll be able to solve for both variables. So the first thing we'll do is I'm going to just divide both sides to get A by itself. So 100 over e to the 2b equals A. Then we'll go over to the other equation and plug that A in. So 300 equals 100 over e to the 2b times e to the 4b. And so if we divide here, 4b minus the 2b, we'll have 300 equals 100 times e to the 2b. Remember, this is just 4 of those and 2 of those, so we'll go 4 minus 2. Rules of exponents. All right, so let's get b by itself. We'll divide by 100. We'll say 3 equals e to the 2b. How do we get rid of e? Natural log of 3 equals 2b. And so we'll divide by 2 to get b. b equals natural log of 3 over 2. And then we'll go back over here for a and solve this. 100 over e to the 2. And we'll plug in what we figured out for b. Natural log of 3 over 2. Those 2's cancel out. And so we'll have e to the natural log of 3. What happens when we have e raised to the power of natural log? They cancel. So the 3's left. So we just have 100 over 3 equals a. All right, so we have our a, we have our b. We can go back and write our final equation. Y equals 100 over 3 e to the natural log of 3 over 2 x. We could then go ahead and plug 5 in for x, and if we plug 5 in for x, we're going to end up with about 520 fruit flies after 5 days if we plug it in. All right, so that's the key. 2 equations for 2 variables. Go ahead and see if you can do the exact same thing on problem 49. All right, 49 coming our way. We have 100 bacteria after 3 hours, so A e to the 3b, and we have 400 bacteria after 5 hours. All right, so we'll get A by itself first. 100 over e to the 3b equals A. We'll plug it in over here. 400 equals 100 over e to the 3b, e to the 5b. You end up with 400 equals 100 e to the 2b, 5 and take away 3. So we'll end up with 4 equals e to the 2b, which we end up with natural log of 4 equals 2b. And now a little bit of logarithm tricks here. Log ln of 4 is the same as 2 squared. We could take that 2 and put it in the front, so we'd have 2 natural log of 2 equals 2b. And so b just equals the natural log of 2. All right, so we have b, natural log of 2. Let's go back and plug it in. 100 over e to the 3 natural log of 2 equals a. Use our logarithm tricks again. 100 equals e to the natural log of, where's this 3 go? It goes up in the exponent, 2 to the 3rd equals a. E and the natural log cancel. We have 100 over 2 cubed, which is 100 over 8, which is 12.5, and that's what a equals. All right, so we have a and we have b, and so we can plug it into our final equation. y, we want a general equation. Y equals 12.5 e to the 3 ln, what am I doing? Not 3. To the ln of 2 times x, or times t for time. All right, so we can go ahead and do this. If we go ahead and plug in 6 for x, y equals 12.5 e ln of 2 times 6. Go ahead, plug that in, and the final answer that you're going to end up with here on problem 49 is roughly 800 if you plug it in correctly.